Let's talk about linear functions. Here's an example of a function that is linear. F of x equals 1/2 x minus 2. And we know that it is linear because the degree of the function is equal to 1. So we got to remember back to what a degree of a function is. It is the exponent, the highest exponent, the largest exponent on an x term. So there's no exponent on this x, so that implies that it is 1. So all linear functions have degree 1. The largest exponent on x is 1. The other characteristic that we can use to identify a linear function is that the graph is a line. Now we have graphed linear functions already. We're going to look at some other things that this linear function in this form gives us. So the form of the function that we have the example of is in this form, mx plus b. Okay, so for our example, our m value is that 1/2, the coefficient on the x term, and b is -2, the constant term. So you can identify those. So what this is called is the slope-intercept form, because that's what the m and the b are. So this is the slope-intercept form of a linear function. So now let's talk a little bit about what slope and intercept is. Okay, b is the y-intercept. All right, so that's going to be where the line, the graph of the line, crosses the y-axis. And m is equal to the slope. Okay, so think about a definition for slope. I know a really common definition is the rise over the run. All right, and we might know what that means. A more maybe descriptive, or another way that we can define that is the rise is a vertical change that the line makes, and so that's going to be the change in the y-coordinate. The run is horizontal change, so that's going to be the change in x. So for our example, let's identify these characteristics. So remember, our example is this 1/2 x minus 2. All right, we said that b is -2, so that means that our y-intercept is the point 0, -2. And the slope, m, is 1/2. Okay, so using our definition of slope, the change in y is 1. It's a positive 1. So that's going to tell us that we're going to go up 1. And then 2 is the change in x. It's positive 2, so we're going to go in the positive direction, which is right. Okay, with that information, we can actually sketch a graph of this linear function. So that y-intercept, -2, that gives us a point that we can plot to start off with. So -2 right there on the y-axis. Now we're going to follow what the slope tells us. It tells us to go up 1 and right 2. So the next point is going to be up 1 and right 2. So we go up 1 to the right 2. We get to the point 2, -1. If we do that again, we go up 1 to the right 2. We get the point 4, 0. We actually get the x-intercept. Now, we can also write that slope as -1 over -2. So -1 over -2 is going to just be positive 1/2, but by putting those negatives, it's going to give us different directions. It's going to tell us to go in the negative direction, or down 1, and then horizontally in the negative direction, which is left. So left 2. So let's go back to that y-intercept and follow those directions. Down 1 and left 2, we get the point -2, -3. We can do that one more time, down 1 to the left 2, and we get the point -4, -4. So we can see how those points line up. They're collinear. We can connect those to finish the graph of that line. And we just plotted 5 points on that line. Of course, there's an infinite number, so we put the line through, put arrows on, and that gives us the graph of that linear function, f of x, or y, equals 1/2 x minus 2. Okay, let's make one observation before we move on to another example. If we talk about whether the graph is increasing or decreasing, we can see that it is increasing for the whole domain from negative infinity to positive infinity. And we also want to make note that the slope is positive. So we have it's increasing with slope greater than 0. Okay, let's look at another example. Okay, let's look at this example. We want to graph this linear function. You notice that it's not in that slope-intercept form. So that's the first thing that we want to do is solve for y. And we'll notice that if we solve for y, it will automatically be in this slope-intercept form. So let's subtract 2x from both sides. And then divide both sides by 3, so we get y equals negative 2/3 x plus 3. Okay. So our y-intercept is 3. All right, we've got b equals 3, so that means we're going to have the point 0, 3 on the graph of the line, and the slope is negative 2/3. Okay, so let's go ahead and plot that y-intercept. Okay, we've got y-intercept right there at 0, 3. Now we're going to use the slope to find other points. It is a negative slope, and that negative we can put on either the numerator or the denominator. So let's put it on the numerator. So we have negative 2 over positive 3. So that's giving us instructions, and the negative 2 is going to tell us that we're going to have a vertical change in the negative direction, so that's going to be down 2. And then positive 3 in the denominator tells us that we're going to go in the positive direction, or right 3. So if we follow those directions and we go down 2 and to the right 3, we get the point 3, 1. And if we do that again, we go down 2 and to the right 3, we get negative, 6, negative 1. Okay, we can also write that slope by putting the negative on the denominator. And then we've got a positive 2 in the numerator, which tells us our vertical change is positive, so we go up 2, and now our horizontal change is negative, so we go left 3. So going back to our y-intercept and follow those directions, we go up 2 to the left 3, and that gives us the point negative 3, 5. And that is probably enough points, but we could use those same directions, up 2, left 2, to get another point. All right, so our points all fall on the same line. We can connect those, and that gives us a graph of that linear function, y equals negative 2/3 x plus 3. Now, let's notice what this graph is doing. As we go left to right, it is it's decreasing, right? It's going down. And notice that we have a negative slope. Our slope is a negative 2/3, so it's decreasing for a slope that is less than 0. Okay, let's go the other direction where we start with the graph of the line and then we write down the equation. So we're looking for, in this form, y equals mx plus b. So we want to identify what b, the y-intercept, is, and then the slope. All right, so to find the y-intercept, we just need to go to the graph, identify where it crosses the y-axis. So there's the point where it crosses the y-axis, and y is 0 there. So our b is 0. And now we got to think about slope. All right, so we just want to remember that it is going to be the change in y over the change in x. So if we go from one point to the next, we just count the change on a number of units of y and in x. So as we go from this point 0, 0 to the point here, which is 1, 2. All right, we can see that we have to go up 2 and to the right 1. So that tells us that our slope is then equal to 2 over 1, or just 2. All right, so for this graph, our equation is just replacing m with 2 and replacing b with 0, we get y equals 2x. All right, y equals 2x. Now let's look at this one. All right, so again, we want to identify the slope and the y-intercept. Well, we can identify that the y-intercept is -1. It's crossing the y-axis at -1. And the slope, as we go from point to point, so as we go from -0, -1 to this point -1, 0, we have to go up 1 and to the left 1. Okay, up 1 is positive, so that's going to be a 1, positive 1, and the left one, left is a negative direction when we think horizontally, so that's going to be -1. So we get slope of -1. So that gives us the equation y equals -1x, or just -x, minus 1. Okay, so we're going to look at finding the equations of a line, a linear function, given different pieces of information. So we'll start off with being given a slope and a y-intercept. So let's say we're given that slope is equal to 1/4 and b is equal to 5. All right, the y-intercept is 5. So what we want to do is we want to write down a linear function in this form, y equals mx plus b. So if we're given those two pieces of information, we just need to make replacements, and we get y equals, replace the m with 1/4, replace the b with 5, and that's the equation of the line. Now we want to look at finding the equation of a line given a slope. All right, so given m, and we don't have the y-intercept, but we have a point on the line. So for example, if we are given a slope of -2 and we're told that the point -3, 1 is on that line, our goal again is to write down y equals mx plus b. We can immediately replace the m with -2, but we don't know what b is. All right, so we get y equals -2x plus b. We need to solve for or find that y-intercept b. Okay, we don't know b, but we do know we have a value for x and we have a value for y. And we could make those replacements in y equals -2x plus b. So we can rewrite this, so replace the y with the 1, and then replace the x with that -3. And then the only thing that we don't know is b, and we can solve for it. All right, so we get 1 equals -2 times -3, we get a +6, plus b, so b ends up being 5. All right, now we've solved for b, so we can write the equation y equals the slope negative 2 times x plus that y-intercept that we just found of 5. All right, let's take another example where we're given, let's say we're given slope is equal to negative 1/4, and we have a 0.83. All right, and we want to find that equation of the line. So first thing we can do is to rewrite, replacing that negative 1/4 for m. And now we take the x and y value that were given in the point and replace those in that equation. So we get 3 equals negative 1/4 times 8 plus b. And now we want to solve for that unknown y-intercept b. So we get 3 equals negative 1/4 times 8 is a negative 2. So we end up with b equals 5. Again, that's coincidence. And our equation is y equals negative 1/4 x plus 5. Now let's look at finding the equation of a line when we're given 2 points. So for example, let's take the 2 points, 3, 2, and negative 3, 4. And our goal is to get y equals mx plus b. So we don't have either of these things. Let's start with finding the slope. So remembering that the slope is the change in y over the change in x, we are going to calculate that slope based on the difference in y, which gives us the change going from one point to the next. So the difference in the y values that were given over the difference in the x values. Okay. Now, in general, we can think of these 2 points that are given as x1, y1, using different subscripts to just distinguish between 2 different values of x and 2 different values of y. So x1, y1, and x2, y2. All right, so in general, then, the equation to find the slope is the difference in the y's, y2 minus y1, over the difference in the x's, x2 minus x1. Okay, so that is your overall equation for the slope. Let's apply that to our 2 points. So if we take 4 minus 2, all right, so we're taking this minus this, over, then we'll take negative 3 minus 3, so then we get negative 3 minus 3 in the denominator. So that gives us a slope of 2 over negative 6. We can reduce that to negative 1/3. We get the m part of our equation, and now we can use that slope and one of the points that we are given to solve for b. So let's take the point 3, 2. So we have y is 2. Then we have m negative 1/3 times x, which is 3, plus b. Okay, so that gives us 2 equals, negative 1/3 times 3 is going to be a negative 1, plus b. So we get, come up here, b equals 2 plus 1, so b equals 3. And those are the 2 pieces that we need, the m and the b, to write the equation of that line. So we get y equals negative 1/3 x plus 3. Here's another example where we want to find the equation of the line through 2 points. First thing to do is to find the slope. So we start by taking the difference between the y values. So we have a negative 7 minus 3 over the difference in the x values, so negative 4 minus 4. Notice that in the numerator we started with the point on the right, and then in the denominator we also started with that point. So whatever y value you start with in the difference, you also want to start the difference for the x values from that same point. We end up with negative 7 minus 3, which is a negative 10, over negative 4 minus 4, which is a negative 8. And we can reduce that and make it positive, since it's a negative over a negative. Gives us a slope of 5/4. Now we are going to make replacements for y and x from one of those points. It doesn't matter which one we choose. We can choose either one, and that's going to help us solve for b. All right, so let's take the first point. So we're going to replace the y with a 3 and replace the x with a 4, and we're going to solve for b. All right, so the 4's are going to cancel out nicely, so those go away. We end up with 3 equals 5 plus b, so b equals 3 minus 5, or negative 2. So our equation of the line is y equals, take our slope, 5/4 x, and then our y-intercept b that we just found, minus 2, and that gives us the equation. Here's another example where we want to find the equation of the line going through these 2 points. So here you might want to pause and work this out on your own and then look at it together. Okay, so we're going to find, first of all, the slope. So we're going to take the difference in the y values. Well, it turns out they're both 2, so we have 2 minus 2. And then we want the difference of the x values, negative 5 minus 3. So we end up with 2 minus 2, or 0, in the numerator over negative 8. Well, 0 over any non-zero number is just 0. So we get slope of 0. If we plug that into our y equals mx plus b, we're going to have 0 times x plus b. Well, 0 times x is just 0, so this just becomes y equals b. So to solve for b, we're going to replace y with the 2 from the points, and we get b equal to 2. So the equation of our line is y equals, I'll just do this again, 0x plus 2. Well, this 0x is just 0, so we don't need to write that at all. We just write y equals 2. Let's look at a graph. Okay, our 2 points that were given, we've got negative 5, 2, and 3, 2. Okay, put the line through those 2 points, and we see we have a horizontal line. So we have a horizontal line. Every single point on that line has y value of 2. So horizontal lines. Also, we think about what slope is. It's the change in y over change in x. Well, y never changes for the change in x. So horizontal lines have slope equal to 0. And the form of the line, instead of being y equals mx plus b, it is just y equals b. And you notice that that is still the y-intercept. So where b equals the y-intercept. Okay, so horizontal lines, they have slope of 0, and they are in the form of y equals b, where b is the y-intercept. Let's find the equation of the line through these 2 points. First, we will find the slope. So we take the difference in the y values, 1 minus 3, over the difference in the x values, negative 2 minus a negative 2. In the numerator, we get negative 2, and in the denominator, we have negative 2 minus a negative 2, so that minus the negative becomes plus 2. So negative 2 plus 2, we get 0. Now we know that when we have 0 in the denominator, that is undefined. So we've got undefined slope. Let's just sketch a quick graph, see what's going on here. Okay, plotting those points, negative 2, 3, negative 2, 1, and we connect those, we see that we get a vertical line. So we got a vertical line, and when we have a vertical line, that has an undefined slope. So vertical lines have undefined slope. If we try to calculate it or we try to find it, we're going to get 0 in the denominator. Also, notice that there is no y-intercept. That vertical line is parallel to the y-axis, so it's never going to cross it or touch it. So vertical lines have undefined slope and no y-intercept. Okay, that means we cannot write the equation of this line in the y equals mx plus b form. There's no m, there is no b. So we write it in the form x equals a, where a is the x-intercept. So just like in the horizontal line, every single y value is the same. In vertical lines, every single x value is the same. And in this case, x is equal to negative 2 for every point on that line. All right, matches up with the x-intercept of negative 2. Okay, so let's take this 1.15 and let's write 2 equations. One, the equation of the vertical line going through that point. Okay, remember that a vertical line has no slope and it has no y-intercept. So we're not going to be able to write it in terms of y equals mx plus b. But every single x value is going to be a 1, including the x-intercept. So the equation is just x equals 1. All right, we just take that 1, and that's what x equals. And now for the horizontal line, this one has to do with the y value, and it is going to be y equals 5. All right, let's do a quick graph. And here's our point, 1, 5, and the vertical line, kind of missed it, but goes through that x-intercept of 1, and so that's x equals 1, and the horizontal line, right, goes through that y-intercept of 5, right, and that gives us that equation for that horizontal line of y equals 5.